I'm Anil Kumar. Welcome to my series on lines, gradients, and angle between lines. Let me thank all the viewers and subscribers for watching my videos and posting excellent feedback. Now, based on the feedback, I've modified one of the questions. Here it is, and I hope now the explanation will help many to understand the concepts better. The question here is, a ray of light passing through point A reflects on the x-axis at point P, K0, and the reflected ray passes through the point B, which is 3, 4. Find the value of K, this value. We have given 4 choices. And a bonus question added to this is, find the angle APB and also find coordinates of circumcenter for the triangle APB, right? So 3 points can always lie on a circle. You have to find center of that circle. You can actually pause the video, answer the question, and then look into my suggestions. Let's try to understand the scenario first. So let me just make a rough sketch here. So we have a point A, let's say somewhere here, minus 3 to me somewhere here, and B is 3, 4 somewhere there. So let's say we have a point here. So that's a ray, it gets reflected and goes like this, correct? What are we given here? We are given that coordinates of point A are minus 3, 2. Coordinates of point P are K, 0, and B are 3, 4. So in the first part, we have to find the coordinates of point P, that is the value of K. So let's try to figure this out. Now, we can always say that the slope M is equal to tan of angle, right? So let's call that angle as alpha. So let us say this line, let this be angle alpha. Now we also know one thing, that any line which is reflected has a unique property that the angle of incidence is equal to angle of reflection. So these two angles are equal, right? So if this is theta, that is also theta, correct? Now if you look into this scenario, you can always see that this angle alpha can also be written as equal to tan of 90 minus alpha, correct? Since this line, which is normal to x-axis, so total is 90 minus theta, sorry. So this angle alpha is 90 minus theta, right? So tan of 90 minus theta is cot theta, correct? Now let's also look into the other angle which A makes with positive x-axis. So let this be the angle beta, right? So we have, so we'll call this as our slope, let's call this as PB, okay. Now the slope A to P will be tan of beta, correct? So, but this angle as a whole is what? Is basically equal to 90 plus theta, right? So since this is 90, that is theta. So we could write this as tan of 90 plus theta. Now tan of 90 plus theta is minus cotangent theta. Is that clear to you? Perfect. So that is how we can actually now relate these two slopes with same angle, theta, right? Now we can equate cotangent and get the solution. So I hope now you understand the concept. Now let's begin. So let's find what is tan of PB, right? So, slope PB. So MPB is equal to, so we'll use y2 minus y1 over x2 minus x1, correct? So in this case, 4 minus 0 over 3 minus k, 3 minus k. And this is equal to cotangent theta. Is that clear to you, right? So from this particular reasoning, we got our equation. Let's call this as 1, this as 2, and we'll call this as 3. Now, so what is the slope a to p? Slope a to p is basically 2 minus 0 over minus 3 minus k. Now this slope should be equal to, let me simplify this, there are too many minus here. Okay, we'll take minus outside. So we get 2 over 3 plus k. Correct? So minus 3 minus k. So we take minus outside. So we get minus, this is 2 minus 0, 3. Now that should be equals to minus cot of theta from 2, right? So this is from 2. And we call this as our equation 4. So this feedback is from here. Earlier we used this equation. Is that clear to you? So what we get here is basically cotangent theta is 2 over 3 plus k, right? So we get cot theta as equal to 2 over 3 plus k. And we also have cot theta equals to 4 over 3 minus k, right? So these are the two equations, 3 and 4, right? So that is one of these equations. So this is 3 and this is 4, right? So, but both should be equal. So now we are going to equate them both and find the value of k. This is the only unknown, right? So we get 2 over 3 plus k equals to 4 over 3 minus k. Is that clear? So we get this relation. Now at this stage, it is very interesting to note that if you really look into, if I drop a perpendicular from here, in that case, we have two right angle triangles. Is it okay? Where this angle is theta, so this is also theta, right? So these, from double A properties, these are also similar triangles. You see, these are similar triangles. So one could have solved this using similar triangles also. So the ratios, which are, this is 2 and this is 4, and this is, 3 plus k and 3 minus k. You get those relations straight from similar triangles also, right? Okay. Now, let's cross multiply. So when you cross multiply, you can actually simplify also and then cross multiply. So we get 2 times 3 minus k equals to 4 times 3 plus k. Now we'll actually simplify. We'll take this away, make it 2. So we get 3 minus k equals to 6 plus 2k. Now taking this on the right side, so we get 3 minus 6 equals to 2k plus k, or we get minus 3 equals to 3k, or we get from here k equals to minus 1. So option B is the right option. Do you see that part? So that is how we are actually going to find the point P, right? So now we know that the point P is actually minus 1, 0. Is that clear to you? Right. Now, as shown here, we could have done the same question using similar triangles. Since we are learning angle between their lines, we use the formula of the concept. This is basic from the concept. The slope is tan theta. Perfect. Now let's move on and answer the other two parts on a fresh page. So I'll just copy this diagram again with k as minus 1, and then we'll see how to find the angle between AP and B. Okay, so let me copy the diagram here. We kind of made something like this. So we had a point on the left side like this, which got reflected, and we got something here. And we also found that this point here is basically minus 1, correct? Let me write minus 1, 0. Point A was given to us as minus 3, 2, and point B was given to us as 3, 4, correct? So that is the scenario. We have assumed that the angles here are, so these angles are theta, correct? We have also, now we can actually find the angle AP, this point is P, right? Okay. So now let us find the angle. So when we are talking about this angle, that becomes not 2 theta becomes the angle, correct? Okay. So the slope M A to P is basically now equal to, now we know this point, right? We can write them the values, 2 minus 0, difference of y value divided by minus 3 minus of minus 1, right? So that gives you 2 over minus 2, which is minus 1, correct? So now let's find the slope of P to B. So slope of P to B is basically equal to 4 minus 0 divided by 3 minus 1. So that is 4 over 4, and that is 1. Well, since these two slopes you can see are negative reciprocal, so we know that since we know M of AP times M of PB is basically negative 1, that means the lines are perpendicular. Clear? So the angle 2 theta is basically equal to 90 degrees, right? So the angle APB is basically equal to 90 degrees. Clear? So that is how we can get the angle APB. Is that clear to you? Now let's look into the next portion, which is to find the coordinates of circumcenter for this particular triangle. So we have a triangle now. So let me connect A with B, right? So let's say this is the point A, B, and P. Now since this is a right angle, right? This is a right angle. That means we are thinking about these 3 points as what? As a semicircle. Do you see that? So definitely these 3 points will be on a circle, right? Whose radius should be such that these 3 points are on the circle. That means when we do like this, do you see that? Then what I've drawn here should be a semicircle. Why? Well, the reason is since the angle APB equals to 90 degrees, AB should be the diameter of the circle. Circumscribing triangle APB. Does it make sense to you? Since this is only in a semicircle, you get 90 degrees angle, right? Right? Therefore, that becomes a diameter. And therefore, the center, which is called which we are interested in finding, circumcenter, is what? Circumcenter will be halfway between AB, is a midpoint of AB, correct? So let's find the midpoint, M. So M is now average of these two values. So it is minus 3 plus 3 divided by 2 and 2 plus 4 divided by 2. So that gives you 0, and that is 6 divided by 2, 0, 3. So this point here becomes the circumcenter for the triangle given to you, right? So our answer here is that circumcenter is at 0, 3. Correct? So that is how we could actually solve the second part of this question also. Perfect. Now as an exercise, what you could do is you can verify the result, right? Check if all these points are same distance, right? So check. Not this. So these 3 points should be the radius, correct? So that is what it is. And it looks like the radius is what? This is 3, right? So the radius is basically equal to square root of 3 square plus 1 square, which is square root of 10. So that is actually the radius for this particular circle, and the center is at 0, 3. Does make sense to you, right? So the question really becomes very interesting once we figure out that the angle between these two lines is 90 degrees. Perfect. I hope you understand and appreciate the concept. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.